Academy. Today we're looking at space physics, and in space physics today we'll be looking at the orbital speed. Okay, we're going to look at the orbital speed, how to calculate the orbital speed. Okay, before we continue, let's take a look at this tutorial.
In this video, we will look at calculations involving objects in circular orbit. Orbital speed is defined as the average speed of an object in orbit around a larger object. Calculations usually involve giving two quantities from orbital speed, orbital period, which is the time taken to complete one orbit, or the distance travelled in one orbit. You can work out the unknown quantity using the familiar equation speed equals distance over time, where the orbital speed is in meters per second, the distance travelled in one orbit is in meters, and the time taken to complete one orbit is in seconds. Look out for the units given in exam questions, as they may be in kilometers per second or kilometers. The distance travelled by an object after completing one orbit is equal to the circumference of a circle. Circumference is equal to 2 pi r, where r is the radius of the circle, or the distance between the two objects. This gives us the equation v equals 2 pi r over t, which relates orbital speed, orbital radius, and orbital period. This equation will not be given in the exam, so make sure you learn it and practice using it. This equation only relates to circular orbits, so you won't be expected to do any calculations on non-circular orbits. Let's put this into practice. The graph shows how the length of an orbit depends on the height above the Earth's surface. A satellite orbits 250 kilometers above the Earth's surface at a speed of 7.8 kilometers per second. Calculate how many complete orbits of the Earth the satellite will make in 24 hours. First, write out the equation relating speed, distance, and time. We have not been given the distance directly, so we must read this from the graph. The height of the satellite above the Earth's surface is 250 kilometers. Reading from the graph, this equates to an orbit of length 41,800 kilometers. So this is our first mark. Next, let's write down all the quantities we know. So the distance travelled by the satellite in one orbit is 41,800. Its orbital speed is 7.8, so we need to work out the orbital period first. Before plugging any numbers into the equation, let's have a quick check of our units. We have distance in kilometers, speed in kilometers per second, so time will be in seconds. Substituting these values into the equation gives an orbital period of 5,359 seconds. Next, we need to find out how many complete orbits the satellite will make in 24 hours. First, we need to convert 24 hours into seconds, which is 24 times 60 minutes times 60 seconds. So, to determine the number of orbits in this time, we simply need to divide this number by the orbital period we just worked out. And this gives us 16.12. But we will round down to 16 as the question asked for the number of complete orbits made by the satellite. You must always check the units on the axes of a graph. In this case, it is in kilometers and not meters. In the calculation, using either unit is fine as long as you are consistent. Let's try a slightly harder example. A satellite orbits the Earth once every 230 minutes, at a speed of 3.1 kilometers per second. Calculate the height in kilometers of the satellite above the Earth's surface. First, write out the equation for orbital speed. Next, let's write down all the quantities we know. The orbital period of the satellite is 230 minutes. To convert this into seconds, we must multiply this by 60. The orbital speed is 3.1 kilometers per second, so we need to work out the orbital radius first. Rearranging for the radius gives us v times t over 2 pi. Our first mark is for substituting the values into this equation, giving us an orbital radius of 6,810 kilometers. Next, we need to determine the height of the satellite above the Earth's surface. The orbital radius r is the total distance from the center of the Earth to the center of the satellite. This distance is equal to the radius of the Earth, which is 6,370 kilometers, but let's call it big R for now. Plus the height above the surface, let's call this h. So the height h is simply equal to the orbital radius we just worked out, minus the radius of the Earth, which we have been given. This gives us a height of 440 kilometers. Drawing a quick diagram can be extremely helpful in questions like this. Being able to visualize the scenario can help you to see the correct calculation and make you less likely to make silly mistakes. In summary, orbital speed is defined as the average speed of an object in orbit around a larger object. It can be calculated using the familiar equation speed equals distance over time, where the distance is the total distance travelled by the object in one orbit, and the time is the time taken to complete one orbit. When radius is used, the distance can be calculated using the circumference of a circle, and orbital speed can be calculated using v equals 2 pi r over t. Don't forget to check out all of our other fantastic...
Okay, so we've just seen the orbital speed, how to calculate the orbital speed, right? It's similar from what we know before. We start from what we know, which is distance. Speed is distance over time. But the distance in this case is a circular distance, okay? The distance in this case is a circular distance. So we're moving in circle. Since we are moving in circle, this distance is like the circumference of a circle. So this distance, d, is equal to the circumference of a circle. So when we're talking about orbital calculation, we see d as the circumference of a circle, which is equal to 2 pi r, which is equal to 2 pi r. So for distance, we'll be replacing with the 2 pi r, where this is the radius of the Earth, where r is the radius of the Earth. Is that okay? Where r is the radius of, or the radius of the two objects, or the radius of one object from the center of the object to the circumference. Is that okay? So this is what we have, and these are the basics we need to know. We already learned or know that speed is distance over time, and this distance can be represented as a 2 pi r, circumference of a circle. 2 pi r over the time is time period. Okay, we're using time period in this regard. Where v is the orbital speed in meters per second, and r is the radius of the orbit, the average radius of the orbit in meters, and t is the orbital period, okay, in seconds. Now this orbital period, or the time period, you used to hear time period in physics. We just use orbit because we're talking about space. Orbital period or time period is defined as the time taken for an object to complete one orbit. The time it takes for an object to move around. One orbit means that you start, let's say you start from here, and then you move around and you reach where you started from. So that time it takes for you to do that is called the orbital period. It's called the orbital period. So the orbital period is the time taken for you to complete one orbit, to move, have one rotation or one revolution. Is that okay? Okay, you can see, for example, if this is the Earth or any planet moving around the sun. This is the sun, this is a planet. So the orbital radius is this distance between these two objects, from the center to the center of these two objects. It's called the orbital radius, okay? It's called the orbital radius. So anytime we are asked to calculate the height, we calculate the orbital radius first. Once we get the orbital radius, we minus the radius of the Earth away from the orbital radius, and then we'll get the height. We'll get the height of the object, of one object above the other one. So these are some questions that you'll be asked. Let's take a look at one example. Let's take a look at an example. It's a Hubble Space Telescope moves in a circular orbit. Its distance above the Earth's surface is 560 kilometers, and the radius of the Earth is, this is the radius of the Earth, is 6,400. This is usually like almost a constant that you need to know. 6,400 approximately is actually 6,300 or something. But approximately, for ease of convenience and calculation, we make it 6,400 kilometers. Now it completes one orbit in 96 minutes. It complete one orbit, that's orbital period. Okay, if you complete one orbit in 96 minutes, we're going to convert this 96 minutes to seconds so that we know the orbital time period. Okay, the capital T, this capital T, orbital time period. So it's 96 minutes. So we multiply by 60 to change it to seconds. Okay, so this is what it is. Let's take a look at it. Okay, first of all, you write the formula. You write the parameter that you're given. We're given the radius of the Earth, 6,400 kilometers. Distance of the telescope above the Earth's surface. The distance above the Earth's surface is 560. Above the Earth's surface, that's the height. So if you add this height to the radius of the Earth, you get your orbital radius. You get your orbital radius. The distance of the Earth of the space or of the telescope above the Earth's surface is 560. This is h. So if you add it to the radius of the Earth, you get what we call the orbital radius. The time period is 96 minutes. So we have to convert to seconds, right? Okay. Now, first of all, we write the formula. What's the formula? The formula is speed is distance over time, and the distance is a circular distance. We say 2 pi r over the orbital period. Now, here we're going to calculate the radius. Okay. Now, why are we calculating the radius? What did the question want from us? Is it a Hubble space telescope moves in a circular orbit? A telescope moves in a circular orbit. Its distance above the Earth's surface is 560, which is the height, and the radius of the Earth is this. It completes one orbit in 96 minutes. Calculate the orbital speed. Now they want us to calculate the speed at which this Hubble telescope was moving above the Earth and what it takes to complete one orbit or one time period. So they want the speed. Before we can find the speed, we have to calculate the orbital radius. Orbital radius is the radius of the Earth plus the height, right? We can use that. Orbital radius, or we use it from the formula. Orbital radius, see, calculate the orbital radius. The orbital radius is the distance from the center of the Earth to the telescope. The distance from the center, look at it, from the center of the Earth. From the center of the Earth to the edge of the Earth is called the radius of the Earth. So if you add the height above the Earth, you get the orbital radius. Orbital radius is always the small arrow. Orbital radius is always the radius of the Earth, which is capital letter, plus the height. This is the radius of the Earth, this one, from here to here. Okay? This is the radius of the Earth, from the center of the Earth to the edge of the Earth, to the highest point of the Earth in the atmosphere. So this is the radius of the Earth. Then anything flying above the Earth's atmosphere, okay? Anything flying above the Earth, the distance is the height above the Earth, So if you add the height plus the radius of the Earth, you get the orbital radius. So we just add the radius of the Earth, we add 560 to the radius of the Earth, we get the orbital radius. Is that okay? So the radius of the Earth is 6,400. This one, keep it in mind. Whether they give you, they don't give you, you have to put it. The capital R, the radius of the Earth, which is capital R. Radius of the Earth. The radius of the Earth, okay, this one is capital R for radius of the Earth. Orbital radius is small r. This orbital radius is equal to the radius of the Earth plus the height above the Earth. The height the other object has above the Earth. Usually we are comparing a satellite or anything above the Earth. So the distance, let's say the thing is flying above the Earth. Let's say it's flying above the Earth. is flying above the Earth. Okay, if the satellite is orbiting, but in this case is Hubble telescope. A Hubble telescope, in some cases, may be a satellite orbiting the Earth. So if it's a satellite that is orbiting the Earth, we can calculate the orbital radius. Orbital radius is always the radius of the Earth plus the height. This place is the height. This place is the height from here to here. You know, when the height above the Earth, the object is flying above the Earth. Okay, we are here in the Earth, somewhere here. So the radius of the Earth is the distance from the center of the Earth to the edge of the Earth atmosphere. To the edge of the Earth atmosphere. That's the radius of the Earth. And this radius of the Earth has a constant value. For ease of calculation, we use 6,400. It's actually 6,380 something. Okay, for ease of calculation, we use 6,400 approximately. We round it to the nearest 100 kilometer. Okay, so this is the radius of the Earth, capital R. Capital R is always, whether it's given in a question or not, we should know this. Now, they've told us the height of the object. The height with which is orbiting above the Earth is 560 kilometers. The height is 560 kilometers. Now, when they ask you to calculate the orbital radius, you simply say orbital radius is this small arrow is the whole distance from the center. Okay, let me use another dimension. The whole distance from the center to where the object is. The whole distance. Like the whole distance. If I use a different color, we can show. The whole distance is the orbital radius. The whole distance. From the center of the Earth to where the object is orbiting is the orbital radius. That's this one. This whole thing is the orbital radius. So that orbital radius is simply the radius of the Earth. And you need to calculate the orbital radius before you can calculate speed. Okay? Plus 560. Plus 560. So when you do this, you get what? They're both in kilometers, so we can simply leave it that. What do you get? You get what? You get 0 here, you get 6 here, you get 9 here, 6960, right? 6960 kilometers. So this is our orbital radius. This is what we're going to use to calculate the speed. This is our orbital radius. Now, if you are asked to calculate the speed, orbital speed is the circumference 2 pi r over the time period. Remember our time period, the time has been given to us over the time period or orbital time. Now, this orbital time has been given. Let's do the conversion. It's 96 minutes. Let's convert it to seconds. 96 minutes times 60. If we multiply 96 by 60, what do we get? We get 5,760. We get 5,000, right? We get 5,760. We get 5,760 seconds. Okay, so now we substitute the value. So orbital speed is equal to 2 times pi. Okay, in this case our pi our pi is our normal pi, right? Is our normal pi value. Okay, so 1 kilometer is 1,000 meters, we know, right? So this much kilometer, 6,960 kilometers will be, you just add 3 zeros to get the meter. Okay, so we calculate. So first of all, we can calculate the distance first. I think the distance we got 6,760 kilometers, which we change to meter. Okay, because we are calculating speed in meter per second. They ask us to calculate speed in meter per second. So let's first of all calculate the distance on top. Okay, the distance is 2 pi r. The distance d, because it's equivalent to the circumference of the circle. The distance is equal to the circumference of a circle because it's an orbit. So orbital distance is 2 pi r. Remember, the radius is is the orbital radius, not the radius of the Earth. Okay, now is the orbital radius. So you say 2 times pi. What's the value of pi? 3.14 times our orbital radius. What's the value of our orbital radius? 66960. So when you calculate, what do you get? Okay, we'll change it to meter. Yeah, to change this one to meter, what do? You remember we have to change this one to meter. It's in kilometer. Our orbital radius was in kilometer. So since it's in kilometer, look at where we wrote the value. Orbital radius equals to 6,960 kilometers. So to change it to meter, it becomes what? You just add 30 because 1 kilometer equals to 1,000 meters. 1 kilometer is equal to 1,000. So we just add 30 in front of this number. That's it. You don't have to worry yourself too much. You have 6960, then you add 30. You add 30. So we add 30. That's 6,960,000 meter. We put the meter. Okay, this is what we get. So we bring the value here. We just add the 30 as well. 1, 2, 3. This is multiplication sign. Okay. And then when you multiply, what do you get for the distance? The distance. What do we get? Okay, when we multiply, we get 696. Okay. Okay, we get this value. Okay, we can simply just say divide by the time period. We can simply say divide by the time period. So just divide it by this value. 57. We'll just divide that number we got by 5760. Divide the number we got by 5760. Okay, we get 758. 75 point, is it point? 75,883, which we approximate 75,090. Okay, yeah, that's it. That's correct. So we get 75. We get 75,000. We get 75,000. 883, right? Okay, so if you approximate this one to the nearest 100, you get 75,090. 75,090 meter per second. Because speed, we convert the distance to meter. So you write meter per second. And we converted the time to seconds. So this is the speed. This is the orbital speed, V. This is V, orbital speed. Okay? These are orbital speed. These are orbital speed. These are orbital speed. So because you now divide with the time. We divide with time. So this is what it is. This is how to use this formula to do some calculation. This is how to use this formula. So first you calculate the distance by multiply the top with the circumference. But to get the orbital radius, you have to add the radius of the Earth plus the height above the Earth, which the other object is moving. So with this, we come to the end of this aspect of our space physics. Thank you for joining us.